In this video, we're going to set up the Animator controller for our enemy, and we're also going to add some code to the game manager to manage and move our enemies. Let's start with the Animator controller. We're going to go to Animations, Animator controller, and open our Animator controller, Enemy 1. We're going to create some transitions from our default idle state to our Enemy 1 attack state by right-clicking on Enemy Idle, selecting Make Transition, and clicking on Enemy 1 Attack. We're also going to transition back to Enemy 1 Idle once Enemy 1 Attack is complete. Next, we're going to set a condition for when we want to transition from Enemy 1 Idle to Enemy 1 Attack. We're going to do this using a trigger parameter as we did in the player. In our list of parameters here, let's click plus, and we'll choose Trigger. We're going to label this Enemy Attack. And we'll add this to our list of conditions from Enemy 1 Idle to Enemy 1 Attack. Make sure that the transition is highlighted by clicking on it, and then we're going to click the plus button in the list of conditions. Since there's only one parameter, Enemy Attack will be added. We're also going to adjust the settings for this transition. We're going to uncheck Has Exit Time since we want to immediately transition when it's time for the enemy to attack. We'll unfold our settings, set the transition duration to 0. Transitioning out of Enemy 1 Attack, we will use Has Exit Time, and we'll set the exit time to 1 because we want to transition at the end of the animation. We'll also set the transition duration to 0. Next, let's dock our animator at the bottom of the screen and test the animation. It's worth noting, because we created our Animator override controller for Enemy 2 and are reusing the Enemy 1 Animator controller, we don't need to do this twice. This same state machine will be used for both enemies. Let's return to our scripts folder and open our Game Manager. First, in Game Manager, we're going to declare a public float called turn delay and initialize it to 0.1 seconds. This is how long the game is going to wait between turns. We're also going to add to our namespace declarations using system.collections.generic. We're going to do this so that we can use lists, which we're going to use to keep track of our enemies. Next, we're going to declare a private list of enemy classes called enemies. We're going to use this list enemies to keep track of our enemies and to send them their orders to move. We're also going to declare a private Boolean called enemies moving. With that done, in awake, we're going to set enemies to equal a new list of the type enemy. In an init game, we're going to clear our list of enemies when the game starts using enemies.clear. We need to do this because the game manager will not be reset when the level starts, and we need to clear out any enemies from the last level. The next thing that we're going to do is declare a coroutine called move enemies. We're going to use this to move our enemies one at a time in sequence. Inside our coroutine, we're going to set enemies moving to true. Next, we're going to yield and wait for the amount of time set in turn delay, in this case, 0.1 seconds. We're also going to check if no enemies have been spawned yet, which would be the case in the first level. If they haven't, we're going to add an additional yield to cause our player to wait even though there's no enemy that they're waiting for. We're checking the length of our enemies list using enemies.count. With our waiting done, we're going to use a for loop to loop through our enemies list and issue the move enemy command to each of these enemies by calling the move enemy function in our enemy script. As we call the move enemy function on each of the enemies in our list, we're going to wait before we call the next one using yield, passing in the move time variable of our enemies. Once we've finished our loop, we're going to set player's turn to equal true and enemies moving to equal false. Now that our Move Enemies coroutine is ready to use, we're going to call that from within Update. The first thing we're going to do in Update is we're going to check if it's the player's turn or enemies moving is already true, meaning the enemies are already moving. If either of those are true, we're going to return and not execute the following code. If neither are true, we're going to start our coroutine, Move Enemies. Next, we're going to declare a public function that returns void called addEnemyToList. It's going to take a parameter of the type enemy called script. We're using addEnemyToList to have the enemies register themselves with the game manager so that the game manager can issue movement orders to them. In addEnemyToList, we're just going to use the add function of our enemies list and pass in our parameter script. And that's all we're going to need to do for now. Let's save our game manager and return to the editor. Now that we've added the needed functionality to the game manager and set up our Animator controllers, we're going to make two small additions to our enemy script. Let's open it up in MonoDevelop. The first thing that we're going to do in the start function is have our enemy script add itself to our list of enemies in Game Manager. By adding our enemy to the list this way, the Game Manager will now be able to call the public function we declared moveEnemy in enemy. Lastly, for the enemy, we're going to use setTrigger to set the enemy attack trigger in the Animator controller that we set up. Let's save our enemy script and return to the editor. Back in the editor, let's add our enemy scripts to our enemy prefabs. We're going to go to Prefabs, Shift-click to highlight the two enemy prefabs, choose Component, Scripts, Enemy. We'll set the blocking layer for both enemies to blocking layer, and we're going to define the player damage variable separately. Enemy 1 is going to do 10 damage, and enemy 2 is going to do 20. This allows us to have a weaker and stronger enemy type to make the game a little more interesting. Let's play our scene and give it a test. When we move the player, we can see that the enemy moves every other turn. We can collect our food pickups. If we collide with the walls, we can attack them and break them. And so far, everything is working nicely. We can see that the player's hit animation is playing and that the enemy attack animation is playing when it should. The next step is going to be to add some user interface elements, including title cards for the levels and some score text so that the player can keep track of their current food point total. We'll do that in the next video.